All right, hey guys. I want to apologize that I can't make it to class today. I'm down in Columbia, but thank you very much for participating and watching this video. We're headed to the third type of demand function that we can draw using our demand functions. So the first one, or the third one, is the cross price demand curve. Okay, so basically what we're looking at is, remember on this side we have the other price, P2, versus our quantity demanded of x1, and we're going to look at how that changes. Close inspection of the two demand functions for x1 and x2 will see that actually P2 does not show up in x1 and P1 does not show up in x2, so the partial derivatives are actually 0 in each case. This is not always true. This is just because it is Cobb-Douglas taste. Remember, Cobb-Douglas taste, if the other good changes price, then it doesn't actually affect our consumption of this good. And so this is just what's going on with Cobb-Douglas. Okay, so we're going to have a perfectly vertical or inelastic cross-price demand curve. Because basically as the price of the other good goes up and down, it does not change from the left or right my consumption of x1 or respectively x2. Okay, this is not true for demand functions in general. So let's just look at the general CES utility function. It's this guy right here, right? Alpha x1 to the negative rho plus 1 minus alpha x2 to the negative rho, the whole thing to the negative 1 over rho. If you were to solve this using one of our three methods, and don't worry, you won't ever have to, I have it here solved for you, you get this really messy demand function. That your demand for x1, the quantity of x1 that you want, is equal to this. You see it's all a function of exogenous variables, so we're done solving. But I do want you to notice that P2 does end up showing up right in here. You guys see that? Now, it's clearly a function of P2. It's kind of hard to figure out exactly what happens as P2 goes up or down, and it actually depends on this value for rho. Now, if you recall, if in the CES utility function I set this rho to 0, then I have Cobb-Douglas. Okay, and that will mean that this P2 will go to 1, which means that we have no cross-price effect. However, if the elasticity of substitution is low, so let's put in a row of like, I don't know, 0.5. So here are the values that we plugged in. Remember, when I graph a demand curve, basically what I have to do is I have to hold everything except for one other variable constant. So I'm going to hold alpha constant at 0.75, P1 to 3, and income to 100. And you see we have this downward sloping cross price elasticity, cross price demand curve. Cobb-Douglas case, of course, when rho is equal to 0, and then if rho is equal to 0, this P2 goes to 1, and once again we have that case where there is no other price in the x1 demand function. So we have the vertical line again, and then of course as the elasticity of substitution rises, which means rho gets closer to negative 1, then we have an upward sloping cross price elasticity. Okay, so it's not always straight up and down. That's just in the Cobb-Douglas case. All right, now we're done with demand functions and demand curves. We're going to jump into labor supply, and we won't actually get to the capital supply portion in this lecture. We'll do that on Monday. But labor supply, okay. Remember that typically we graph in the labor market, we graph the labor supply curve as upward sloping, just like I've showed you in class. We put the wage on the vertical axis and the quantity of labor on the x-axis, right, on the horizontal axis. And we have a upward sloping labor supply curve. It's generally what we assume. We assume that as wage goes up, that people supply more labor. Well, that's just a macro model. Let's investigate the micro level foundations that either confirm or deny that fact. Okay, so let's go ahead and have the guy be at an optimal point at A. He increases his wage, then his wages increase for him to 25, and we want to ask exactly what does he do? Does he work more or does he work less? Well, let's first examine the substitution effect. So I'm going to suck away the income from him. B is the point that lies along this compensated budget line where I sucked away the income from him. Now, the substitution effect always points towards the relatively now cheaper good. So since the wage went up, it's more expensive to sit on your derriere, and therefore we're going to substitute away from leisure toward working. Okay? So if I draw this here, I have the wage, I have leisure down here, and I substitute away from A to B, from 20 hours of leisure to 10 hours of leisure when the wage goes up. Okay? And if leisure's, that's a substitution effect, then if leisure is a normal good, C must, well, as it comes over here, as I give him the income back, it must lie to the right of B. It could possibly even lie to the right of A. If the wealth effect is so huge it's bigger than the substitution effect, you see how I have the wealth effect? Then what we were going to have is an upward sloping leisure demand curve. And wait for it, we're not quite there yet. The thing we're trying to find is labor supply curve, not a leisure demand curve. Don't forget, how much labor do I supply? It's just my total number of hours minus my leisure. So if I actually want to see labor supply, then the labor supply at point C goes from 60 to 25 hours. Okay, what's that, 35 hours? So it used to be at point A, it was 40 hours, and then it decreased to 35 hours. So when I go ahead and draw that here, I'm going to go ahead and draw point C at 35 hours and point A at 40 hours. See what I've done? I've changed the axis here to hours of labor, no longer is it hours of leisure. And then I have a downward sloping labor supply curve. Okay, so this is really important because it goes against what neoclassical economics always assumes, which is an upward sloping labor supply curve. Basically, it is possible to generate a downward sloping labor supply curve just by having a wealth effect that is so big it pushes C to, when the wage goes up, to actually work less. Okay, and so that I just want to point out. However, the typical upward sloping labor supply curve can be generated in one of the following ways. Okay, let's suppose that the wealth effect isn't that large, so the substitution effect goes to A to B, and then the wealth effect goes B to C, but it's rather small. Okay, so we have this big blue substitution effect and a small wealth effect. That means that our labor demand curve is going to go from A to C, and so leisure demand, not labor demand. Leisure demand curve is downward sloping. In other words, at the low wage he worked 40 hours, and then at the high wage he worked an extra 5 hours, as you can see. So that's going to be an upward sloping labor supply curve. This is typically what we assume, right? So he has 40 hours of labor, and then it goes to 45 hours of labor. Because the substitution effect pushes him to work a whole lot more, but then the wealth effect says, hey, don't work so much, leisure more, buy more leisure. Okay, so this is important. Depending on the size of the substitution effect, relative to the wealth effect, the labor supply curve may slope either up or down when leisure is a normal good. Okay, and if leisure is an inferior good, then C must lie to the left, you see. So the substitution effect and the wealth effect are going to point in the same direction, substitution effect, wealth effect. So then we're going to have a leisure demand curve, which is downward sloping, and by definition, we must have an upward sloping labor supply curve, okay? So this is important. Labor supply must slope up when leisure is an inferior good, okay? Now I want you to think just a little bit about what would happen if leisure were quasi-linear, which would mean C is right above here. Think about what that would generate in our labor supply curve, okay? All right, let's look at it mathematically. So how do we find these labor supply functions? Well, they emerge from the worker's utility maximization problem. So don't forget that the worker is maximizing their utility, right here, utility of consumption and leisure, subject to the wage times cap L, which is the total amount of money that hours they have. This is the total amount of money they could earn. They split it between two things. They split it between consumption and towards leisure, and leisure costs wage dollars per hour. This gives us the answers for leisure and consumption, just like we've done before. And notice here I have the italic L for leisure, and I'll have the curly L for labor. I'll try to keep that consistent, okay? But I do want to point out that this leisure will have a wage and a cap L in it if I don't specify them. If I just leave them as variables in my original maximization problem, they will have a wage, they will have a cap L in it, okay? So there'll be functions of that. Then in order to get from my, so there's the leisure demand, there's the consumption demand. In order to get to my labor supply, all I do, my labor supply curve, I just take cap L, subtract minus whatever value I got for my leisure demand right here. I just subtract it off, right? So if I want to leisure for 20 hours and I have 60 total hours available, then my labor supply is going to be 60, take away 20, which is just 40 hours, okay? All right. So let's suppose, for instance, that a worker's tastes can be represented by this following function. Notice this is most assuredly quasi-linear in leisure, okay? I'm actually not going to work out this one because it's kind of difficult to do, but I will first show you, talk to you how to do it, and then I have a video of me working out a very similar problem. I'll show you in a second, okay? So if you go ahead and solve this, we're going to maximize this subject to his budget constraint. You can go ahead and set the MRS, find the MRS here, and set it equal to P1 over P2. Well, the MRS here is pretty easy to find. It's just partial U partial leisure divided by partial U partial C. Partial U partial leisure is just this. It's going to be alpha over leisure, okay? Partial U partial C is just going to be 1. So the whole entire MRS here is just going to be alpha over leisure. And you can set it equal to wage, because wage is basically P1, and P2 is 1 because it's a composite good. So P1 over P2 is actually just wage, W. So you set alpha over leisure equal to wage, and that's how you get leisure equals alpha over wage after you just flip the spots of wage and leisure, okay? And then plug this into the budget constraint to get consumption equals this guy right here. All right, so how much leisure is the guy going to demand? He's going to demand alpha over wage, whatever that is. And if I want to know how much labor supply he's going to supply, I just subtract this number from capital L. So my labor supply is just going to be capital L minus alpha over W. That's my labor supply function. Finally, don't forget that all graphs in economics, almost all graphs, are backwards. So instead of having labor here and wage here, which makes sense to us, we're going to have to solve this out for wage because wage is on the vertical axis. So what can I do? Well, I can add alpha over wage to this side, subtract leisure or subtract labor from this side, and then multiply both sides by wage to get wage all by itself, and I end up with this right here. Okay, so after a little algebra, I get wage is equal to alpha over cap L minus leisure. Okay, and then I can go ahead and graph that because I have W and I have labor and I have these variables right here. I'm going to have to set alpha and cap L equal to something in order to be able to graph it, because otherwise it will be too many dimensions. So let's set alpha equals to 400, and let's draw a couple of different curves. This one's when cap L is 60. This one when cap L is only 40. In both cases, though, labor supply is upward sloping. Okay, so this came from quasi-linear. Remember the question I asked you about 5 minutes ago, what will happen to labor supply when leisure is quasi-linear? We showed mathematically, coming from a quasi-linear utility function, that labor supply is always upward sloping. Okay, I also want you guys on MindTap here, let me show you actually. Let's pull up in MindTap real quick. If you go away from the calendar view and you go to the unit view, right here, Chapter 9 video walkthroughs, click on that, and there is 2 videos here. For your purposes, this one's the more important one to click on that, and there's a video of me working through one of these problems, but in Cobb-Douglas, not quasi-linear. However, that should be really important, and you should definitely check it out before Monday. Okay, we're almost done here. So the reason that labor supply always slopes up in the quasi-linear case is because there is only a substitution effect when the quasi-linear case, right? So when the wage goes up, the substitution effect says, hey, work more. There is no wealth effect to counterbalance it, to say, hey, you might want to work less because we're buying more of everything, including leisure, right? So the substitution effect is always pointing in the direction of more labor as wage rises, right? However, when leisure is a normal good, you do have a wealth effect, and it will point in the opposite direction, and it just depends upon if the wealth effect is bigger or not than the substitution effect. Right? So let's pull up our good old CES utility function right here. When rho equals 0, okay, let's throw a rho is equal to 0 in here. We know that tastes are Cobb-Douglas, and this is actually the one of the examples I do in that video you should watch that I just showed you. When rho equals 0, tastes are Cobb-Douglas, and don't forget with Cobb-Douglas, tastes, substitution, and wealth effects exactly offset, so you have an exactly vertical labor supply curve. If you have lower values of rho, okay, that means so closer to -1. Remember, as you get to close to -1, that's perfect substitutes. So you're going to have a really big substitution effect, which means as wage goes up, it's going to push you towards more labor. So then we have an upward sloping labor supply curve when rho is close to perfect substitutes. When rho is high, meaning perfect complements, we actually have a downward sloping labor demand curve, which means that when I get paid more, I want to go ahead and consume more leisure to go along with my higher wage, right? Because they're complementary. Oops. So that's all of the slides that I wanted to go over today with you guys. Good luck. Thank you for watching, and I'll see you guys on Monday.